Thank you very much for coming. Welcome to Visual Studio and Xamarin. When I wrote these slides, I didn't realize that it was going to be called the future of app development. So I feel like it's a little bit like too magnanimous, too pompous to make that claim. So I should probably edit that, but it's too late now, folks. So today I want to talk about mobile applications and what we can do for you when you're building these applications. And before I was coming here, I was watching some documentary about how mass media grew up in the United States. And and the whole TV industry and the newspaper industry, they grew on the back of reaching people, and they grew on the advertising business. And what is interesting about mobile is that, and at that point, there were a couple of focal points where you would, where people would go to reach users, right? So that's why the press was so important. And now with mobile, you have a way of talking directly to people via their mobile devices and reaching out to them via their mobile devices. Just a couple of interesting data points. 80% of people, of internet users, have a smartphone, right? And 77% of Americans have a smartphone today. So if you're trying to reach a big market, building a mobile application is a pretty good way of doing that. Some of the other statistics that are pretty interesting are that people in the United States, on average, use 10 applications per day. Brazil is the #1 country. Apparently, those guys are up to 12 applications per day. So we got a lot of catch-up to do there, folks. Between Google and Apple, there are 3 billion devices, right? So there's 2 billion for Android, 1 billion of active devices for iOS today. That's just a lot of devices. So this is a big market. And the other thing that was very interesting is last year, Apple reported $11 billion of revenue on the App Store, right? So these are people that purchased either applications or subscriptions or in-app purchases on their App Store. Of those 11 billion, 1 billion was sold between Christmas and New Year's Eve, and New Year's Eve was 300 million, which essentially shows that when you're stuck with your family on New Year's Eve, you naturally go to the App Store. So now, as you embark on a mobile project, I imagine that many of you will get started on your application, and probably is going to be in the shortest project. It's probably going to be a 3-month engagement, right? A small application will probably take you 3 months, and you'll build your app, you'll design your app, you'll test it with customers, you'll roll it out. You have to go through the whole app submission process many times. And if you're lucky, you'll wrap that up in 3 months. If not, you're going to spend a year or maybe years maintaining your app. We have customers that have been maintaining their Xamarin apps for 5 years now. So it's a long process. As we talk to customers and I talk to our users, there's a couple of insights that I wanted to share with you. And like Satya said yesterday, we succeed when you succeed. So we want to make sure that you guys are successful. So I want to talk to you a little bit about some of the challenges that you have with your applications. Today, somebody was telling me, hey, is there just some automatic way that I can take an app and convert it to be a Xamarin app, right? There was a Channel 9 discussion about an hour ago. And I said, no, what you really want to do is you want to make sure that you embrace the native platform. You want to make sure that you have a great application on Android, a great application on iOS, and that you embrace the platform. And one interesting tidbit here is that of people that download your application, in the long term, you only retain 55% of those, right? Now, if your users launch your application at least once in the second week, you'll retain 82% of those users, right? And if you don't, that number drops to 37. So this is the 3-month engagement. This is what the numbers look on a 3-month engagement. And you can see the happy path. If you manage to get your users, right, and there's a source down there. If you manage to get your users to use your application at least once a week, chances are you're going to retain that customer, 90% chance that you're going to retain those customers. But if you mess up your onboarding experience, you're going to end up with 23. So you'll only retain 23% of your users. So, so you really want to get this right? I mean, the drop-off there is significant, 82 and 37, just from people that try your application on the second week. So, so what can you do about this? So first off, your app has to be good on day one. You cannot launch a half-assed app. You cannot launch a bad app. You really need to polish that app. So we're going to talk a little bit about that today and what we can do to help you do those things. But the first question that I want to ask you is, does anybody know how to make that number smaller? So we just saw that there's a number of mistakes that you can make along the way that are going to get you into that ugly 23%. So you spent the best years of your life. I mean, some of you look pretty young. Some of you. And you're going to spend your best days of your life, time that you're not spending with family, building this app, and then most people won't care. So the question is, do you know what automatically drops your adoption by 50%? There's one thing that people do that automatically drops their adoption by 50%. Does anybody know? Which one? Bad app reviews, that's one option? Not quite? What? Painful rating? Experience crashing? Notification? That comes later if you get past that point. No, somebody just mentioned it here. If your application requires a login, if the first thing that your app does is, all right, sign up or log in to use the application, you already lost half the people. There goes your life. It's gone. You might as well not even show up to work. Selling hamburgers is probably more profitable business. So here's a couple of examples of applications that I do like. And the first one is Tableau. It's a data analytics application. And what I like about Tableau is that it really is an application that will work with your data. So you really need to have a sign-in mechanism. You can't really avoid it. But what the Tableau people have done is that they've made a bunch of existing data sets that you can browse. So you can download the application, and you can actually browse the applications and the data and play with the data, experiment with the data, and get a feel for what the app can do. So that is a really good use of this thing. Overcast is also one of my favorite applications. It's a podcast application. And what I really like about this is that Overcast manages to keep a lot of state associated with you without ever requiring you to log in. You can log in, and your experience is much better, but you don't have to log in. So this is some of the things that you can do. And of course, you can see that I'm a subscriber to Merge Conflict. So some of the things that you can do to improve the adoption of your application is, first of all, you need to have a good onboarding experience. And this is an interesting thing. If you come up, many of you sometimes are not looking at how Android and iOS behave. And you're inventing your own UI interaction modes. I'm not going to name names, but I see you in the audience. And kudos for inventing a new UI interaction system. But most people feel very uncomfortable using this thing. So I think that a good rule is that if you're going to ever invent a new interaction system, you should have a walkthrough, Do a full walkthrough of how you're going to do that. And that should discourage you the moment that you think, I'm going to have to do a walkthrough and a tutorial. So you should think every time that you're trying to come up with something clever that you're going to have to do a walkthrough and go through all the pain that that's going to involve. So you should really just do what the operating system does. Now, that said, when you introduce new features, it is very useful for your features to gain adoption to have one of these interstitial pages. Apple is using this idiom on all their new apps, and they highlight a couple of features. So instead of having very long release notes or on the update page that nobody ever reads, especially if you have automatic updates, nobody ever reads your release notes, you want to highlight some of the new capabilities in your application. And what is interesting really is, Apple uses this, and a lot of people have copied that. You can see that, for example, Office uses this as well on their desktop applications. These are two very interesting ones. The first one is a Google application that lets you explore the world in 3D. So when you move when you move the phone, that image that you see is a 3D. It's a 3D rendering of the space. So you can look at what kind of experience you're about to enjoy. And the other one is Paper. I like Paper because their first page, it's actually, this is a note-taking app or a painting app. And they use the app itself to be a tutorial. So when you tap on that notebook, this is how the application started. When you tap on that notebook, there's a tutorial, and it shows you how to use the application. So you should think about what do you want to do to make people comfortable with your application and make sure that they use it. This is a recent addition to the Azure mobile app. It used to be one of those apps that the first thing that it did is login and password. And it was just horrible. Also, the login entry was the wrong font, the wrong size, everything that could go wrong about that app was wrong on the login screen. But now they have a nice carousel, nice onboarding experience, and the UI is much more improved. Now, I want to talk today about how we can help you in multiple stages of your application. And we're going to start today with design. And I know that that's not what you came for. I know that you came here to talk about properties and C# and events and CLI and C# compiler and things like that. But I think that we need to start here. So the first thing to keep in mind is that whenever you say design, and I know many of you are programmers, and you're thinking, well, this is not my cup of tea. We have professional people that do this. I don't have the gene. I was born without it. Or I fell on the wrong side of bed when I was a kid. I can't do design. And I want to dispel that myth because you can do design. You just need to understand your user. You actually need to put yourself in their shoes. And one of my favorite books on design is Joel Spolsky's User Interface Programming for Developers. Joel Spolsky is the founder of Stack Overflow and Fog Creek Software. It's a great book because it essentially, for me, it made design approachable. I'm a software engineer. I know how to write code. I know how to compile things and pass flags to the compiler. But I always thought that design was a very intimidating process. And you don't need to hire a designer. You just need to understand your user and put yourself in their shoes. And this is a great book to get started there. So we'll talk about this for a little bit. So the first thing that you have to ask yourself when you're building your app is, what problem are you trying to solve with your application, right? And one of the problems that we've seen with our users, with a lot of our Xamarin customers, is you are .NET developers, and your boss says, let's put this on mobile. And the first thing that you do is you try to cram either your website or your desktop application into mobile. And what you need to understand really is that mobile, you don't have to replicate everything in your website into a mobile app, and you don't have to get the same desktop experience on a mobile app. In fact, you really need to think about how are people going to be using your mobile application, in what environments they're going to use it, and what pieces does it make sense to bring. So there's some pieces of code that you'll be able to take. Just take those pieces, but don't bring the whole thing. And there's really good guidance. There's incredibly good guidance coming out of the Microsoft design team. So as you guys have heard Satya talk about this, there's a big push in the company for accessibility and inclusivity. And these guys put together a fantastic, these folks put a fantastic set of documents on inclusive design. And it is very relevant for how you build mobile applications. I was really surprised how much of this applies. So first of all, again, so we go back to what is your app is trying to do, right? And you might say, well, we want to make sure that we reach the customers. So if we're a restaurant, we're going to reach the customers. And the things that you have to think about is, where are people going to be using your app, right? So this is really one of the key questions. Where are people going to be using your application? Right? They're going to be sitting comfortably in the couch, they're going to be on a desk, or they're going to be driving, right? So that will completely change the kind of user experience that we really will provide, right? A podcast application probably needs to have very big fat controls, right? Because you're probably driving, and you probably shouldn't do that anyways. but directions, GPS directions are a good example. Or you're going to be using this when you're walking in downtown, right? And you need to pay attention, so you probably don't want to distract people, right? So this is a very good framework for starting to think about what your application needs to do, and then you'll start removing features. There's a lot of things that don't make sense in this environment. You'll start dropping things. There are things that you just don't need to have. In particular, if you're at home, well, just go sit down in the computer and finish your job there. The other thing is how they're going to be using your application, right? So there's nothing more obnoxious than going to lunch and people at the table looking at their phones, right? So you should consider what kind of what are you going to be using it? Are you going to be playing alone? Are you going to be in the bus playing along with this thing, or is it going to be a networked game, or is this something that is going to require a network connection, for example, or one of those games that you play, like that game that you put the thing on your face, right? So it's a game activity. You need to use Game Center. You need to use local connectivity for those things. You might not even trust the network. The host of the house might not trust you with his password, right? So there's a lot of considerations that will come in here. And this is probably my favorite. When we talk about accessibility, a lot of people think that, well, I design for people that that have every possible ability, right? And I know that it's a small percentage of people that maybe have problems with colors, for example. And what I really like about this piece of the Microsoft inclusive design is that when we think about accessibility, we tend to think about the permanent elements. Ooh, Pierce, I'm going to need your login at some point. So we tend to think about the left column, right? These are disabilities that are permanent, but I really like this framework where you think about temporary disabilities, right? I've broken my arms twice, right? And I couldn't move my arms for 2 months each time I did that. And it changes your view on how you use software. I used voice dictation for months, right? And that's how I wrote code, and that's how I wrote emails, right? It was all voice dictation. Or, I have 3 kids, and when you have to take care of your kid, you don't necessarily have access to all of your things. So things like Alexa or Google are very useful in that scenario. And the same thing happens here, right? Or you're driving, right? Well, then it means that your application will not be usable if you need to look at this thing. So I strongly recommend that you look at these design elements as you build your application, and you look at the Microsoft inclusive design. They have both, they have materials, they have explanations, they have exercises that you should go through as you build your application. And the reason is, you're going to be spending, if you think about it, you're going to be spending a ton of money building this app. You're going to spend $300,000, $400,000 for a small app, just salary-wise. And so you might as well just save yourself some money. And let me tell you how you're going to save some money. Before you write a single line of code, I think that you should be designing this thing on paper. You should take a piece of paper, and you should draw what your user interface looks like, and what the transitions are, and what kind of thing you're going to be building. This is incredibly cheap. You can design this in an afternoon. And getting that design set in place in one afternoon, or maybe even a week, will save you, down the line, a lot of money. There was a quote. I'm going to have to get that quote. There's a beautiful quote about people that don't design and they just launch themselves into coding. Now, you might, one of my favorite tools is, once you do this paper design, I use Adobe's XD software. And what I like about Adobe's XD is that there's a bunch of toolkits. I'll show you a screenshot of this. They have these wireframe toolkits with all kinds of existing idioms that you can borrow from. So one of the things that our community, our .NET community is, and I don't know why it's a .NET thing or a Microsoft thing, but we tend to invent user interfaces suitable for people from a different galaxy and different number of limbs. So this is a good starting point, because you can start building your wireframes based on some professionally built UIs. So Adobe XD comes with these wireframes, both for iOS, Android, and a bunch of other things. But the other thing that it lets you do is it lets you prototype the UI very quickly. So you prototype the UI, you prototype the interactions, and then you can publish that URL, and you can send it to somebody else so they can try it on their phone. So you can try this app, and you can see what it feels like. It's all fake. There's no real data. right? But you get a feel for how the application would be used, and you can get immediately feedback before you write a single line of code, and you have to set up the Android SDK, install the Hyper-V emulator, and download the templates and the 10 NuGets, and resolve all these problems, right? So you save a ton of time if you actually plan this ahead of time. And I'll give you an example. The first thing that I wanted to build was, when I first started building iOS applications, was a currency converter and a temperature converter. I'm Mexican, so I speak Celsius. I don't speak whatever that thing they speak here. So I built a terrible user interface. I probably still have it somewhere. It was terrible, and I had no idea what I was doing. But today, you can get a lot of inspiration for what people are doing with very simple information. So this number 27, I collected a few ways of rendering the number 27 Celsius with some of my favorite apps. Those are the apps that I use on my phone. I use a lot of weather apps because I live in Boston. You have no choice. But these are a couple of I don't know what is doing this thing, so let me just switch right here. But these are different ways of representing the same information, and you can see that the Yahoo one is probably one of my favorites. They link the data to Flickr. I don't know what they're going to do now, but they link the data to Flickr, and it's the same information, right? But when I built my app, I was like, okay, I got the temperature. What else should I put? Right? I had a radio button, Fahrenheit and Celsius. Like, what else can you put there? Nothing, right? So the reality is that you can borrow ideas from others, you can think about different designs, and you can explore the space. Now let's talk a little bit about what we can do. So this is the things that we can do for you. But before we get here, I think, yes. So the next section is all about how can Xamarin help you, or how can Visual Studio help you build mobile applications. So not all of you know exactly what we do, so I'm going to take a couple of minutes to explain what we do. So what we do is we took .NET, the .NET runtime, and we made it run on Android and iOS. It's very simple. The concept is very simple. And the benefit of this is that now you can use .NET code to target multiple platforms. And not shown in the slide are other platforms that we support. We can also run on Tizen, we run on macOS, we run on PlayStation, on Xbox. It's not the point. The point is that we essentially will get your code running on every platform out there. And what is nice about this is that you can share the code across the platforms. And now, we have a number of options for you. You can either write targeting the native APIs of each platform. So you will write an iOS UI or an Android-specific UI, or we can give you a write once, run anywhere API. So we'll discuss that a little bit in a second. But the key to Xamarin is, and .NET is that we make sure that the user interfaces that you build are going to feel native on every platform, so that you're never at a disadvantage, right? So when you use .NET and Visual Studio, you will be able to create user experiences that are indistinguishable from an Android native API or an iOS native API. So this is key for us. And we make sure that we give you access to every API that the native platform has. So we're very proud of our one-to-one mappings to the underlying platform. And this is not just an API mapping. We do an object-oriented mapping. So what that means is that if you create a C# subclass of a native object, right? So let's say that the native platform has a UI view class, right? That's the iOS view. And you create a C# subclass of UI view. As far as the operating system and the environment are concerned, these two are first-class citizens, right? So you can create C# classes and pass them over to iOS APIs and the other way around. We've done this so much that we even allow you to take .NET code and embed it into native iOS APIs, either in Objective-C or Swift. So you can either run your whole app as a .NET app, or you can embed .NET into an existing Swift or Objective-C app or Java app in the Android case. The other thing that we take a lot of pride on, and I'm not going to go into the details here, but we spent a lot of time making sure that we support every API that Android ships and every API that iOS ships. This is great for you, the user. It's miserable for my team that has to work through the summer. You might not know this, but Android P was just released today, so the team is already working on Android P. iOS will have their major next release in a couple of weeks at WWDC. So that means that our summers are typically ruined because we have to work on this nonstop. Then the other thing that is very interesting is that we convert .NET code to LVM bytecode. And for those of you that don't know, LVM is an optimizing compiler that has been under development for the last decade. And it is the native compiler of Apple's platforms. But it's also now universally used. Even Windows uses parts of LVM. And it's probably one of the best code generators in the world. So we use the LVM optimizing compiler to generate code both on iOS and on Android. So if you ignore the safety guarantees of .NET, you'll get code that is as fast using .NET code as the native equivalents are. And I added that caveat because C# adds a little bit of overhead to native code. And the canonical example is when you access an array, we need to check that the array element is between 0 and the number of elements in the array. And if you get outside of bounds, we'll throw an exception. The native platform instead, when you do that, it just says, yeah, sure, we'll access that data. We'll write data here left and right, and it will corrupt the state of your application. I don't know what he did, but that looks good. And we also take a lot of pride in making sure that we support all these capabilities of the native operating system on launch date so that you are not left behind. So I'll give you an example of a timeline. Google today is launching Android P. We're going to have previews of the Android P APIs early in the summer, in a couple of weeks. And you'll start to use it. You'll give us some feedback if you really need those capabilities. Like today, they announced slices. So you'll probably start using slices in a couple of weeks. And then we'll improve that thing. So you can start developing your application supporting the new technologies as the beta progresses through the summer, right? So typically, both Apple and Google release their major OS updates in the fall. So you have the whole summer. So in theory, also your summer is ruined. And you get a chance to take advantage of these APIs and hopefully get featured by those stores on launch date. But we have your back. Essentially, that's what you need to know. So now let's talk about so we've done a lot of improvements in all of these areas. So this is a convenient PowerPoint slide. So I really like this design. I didn't have to think too much about this. So let's talk about the different pieces and what we can do for you. So first of all, we have a great team working on this. What I'm going to show, it's a collaboration both of the team that came from Xamarin, the Visual Studio team, the .NET team, and the Windows team. So we have actually a lot of people working on this thing. And as your projects have grown in the last couple of years and you took more NuGet dependencies and you started to consume more libraries and your projects grew from one tiny project to dozens of projects and extensions and watches and all kinds of other junk, the builds got slower and more complicated. So a lot of the work that we've done this year is centered around how we can improve your development experience. So we'll talk about the tooling improvements next. So first off, we wanted to improve the setup experience. And there's a lot of things that we're doing. First off, in the past, we had this hemorrhage of templates on Visual Studio. So to get started, you would pick among multiple nodes, single view, multiple view, shared, not shared, though maybe not shared, Android, maybe multi-platform, iOS, mobile, and then you had to look for the right combination. Now we have a single template. You pick this template. You choose which platforms you want to target, Android, iOS, UWP, which UI stack do you want to choose, and what style of code sharing you want. Some people like share projects like me. That's why it's the default on that screenshot. And some of you like to shoot yourself in the foot, and you like more abstraction, so you'll use library projects. So we've done that, and the other thing that we're doing is when it comes to getting you up to speed, right now we require you to, in the iOS case, to first set up your machine, install all your bits on your machine, then go to the Mac and follow a separate set of instructions, and then connect those two together. So we've decided to make that a lot simpler. So now when you launch Visual Studio, and you configure your Mac, we'll say, hey, there's a Mac over there. You want to use that Mac? And it's like, sure. You'll type in your credentials. You log into the Mac. It will validate if you have the right Xcode. If you don't have the right Xcode, we'll download that Xcode. We'll get the license. You'll agree to the license. We'll configure Xcode to actually have the tooling installed, and you'll be off to the races. So we think that this is going to improve the workflow for a lot of you. Oh, and in fact, I have a little video. I don't think I'm going to let it continue because it's a long video and it shows every single bit of the provisioning experience. But you can download the slides and the video will be there. Then the other thing that we've done is Google recently removed the Android device manager from the Android SDK. So if you updated to a recent version of the Android SDK, you could no longer do this work. You had to switch to Android Studio, configure your devices there, go back to Visual Studio. It was a little bit confusing. Some people couldn't find it. So we built a new Android device manager. So you can do everything now from Visual Studio. We have both editions for Mac and Windows. The other thing that they did is they removed the SDK manager. And that was a curse and a blessing. First, a curse because all of you were confused. You didn't know where to go. It was messy. The blessing is that this gave us a chance to actually curate the feeds so that we make sure that the right packages are available at the right time for you. So we integrate both this on Android and on Mac and Windows. Now, one of the problems that Android brings really is that Android is a very fragmented ecosystem. You have a wide spectrum of devices, a wide spectrum of operating system releases. Different teams and different projects even choose different targets. So for example, one team might say, I need to run on very old devices. So you need to support Android Lollipop, right? And another team wants to be on the edge, so they're OK taking a dependency on Android Marshmallow, right? So just going back and forth and setting up all the dependencies has historically been one of the most frustrating pieces of dealing with Xamarin. I heard this. I hear it almost every day. You guys complain constantly. So it's not, it's not the fanciest work in terms of compiler design or language design, but we had to fix it. So we had to do something about it. And also, when you go to GitHub and you download a sample, chances are that sample is not using the right version of Android, right? It's using some random version of Android. It's going to be different from what you have. And it was our fault. It's not our, what is it? Anyways, it was our fault, and you had to go through a very painful experience. So we implemented the automatic SDK management. So now whenever you open an Android solution that somebody else built, we will go and provision the right Android SDK for you. So all of that is gone, and hopefully my inbox will be a happier place. Then I wanted to show you this, but I have a little problem right now, so I'm not going to do that. But one of the things, one of the collaborations that we had with the Visual Studio team is, it turns out the XAML editor in Visual Studio was designed for UWP and WPF. And it was very tough for us to hook into that thing. So we had to build a separate XAML designer. So historically, when you use Visual Studio, you had really two XAML designers, the one for WPF and UWP, and the one that was built just for Xamarin Forms. And that means that a lot of the capabilities that you come to expect from the XAML editing were just not there. They were just not available. And that means code completion was not the same. Whenever you saw a keynote announcement about, for example, the MASI, the matching fuzzy strings, it was not there. Substrings matching wasn't there. There was no light bulbs. None of these capabilities. And even doing code completion for bindings, when you do binding context space something, you wouldn't even get that experience, right? Because there were really two separate code bases, and we just hadn't gotten around to re-implementing everything that the Visual Studio team had done. So the good news is that that is a thing of the past, and now the Visual Studio XAML editor is what you come to expect is the same one that you're using for UWP and WPF, and all those capabilities are now there. Now, the other thing that has started to happen in the last couple of years is that Apple introduced this concept of size classes. And size classes allow you to build a single app that can target multiple form factors. And essentially, the way that you should think about your applications now is not that you're building a mobile phone app or an iPad app. You really should be thinking about whether you're being displayed in wide mode, regular mode, or compact mode. These show up, for example, when you have a mobile app and you tilt it in one side. Well, you have a little bit more of width, but you have a short height. And it's not shown here, but if you click on these options, what happens with the iPad is that now you can run mobile apps side by side a bigger app. And there's multiple modes of operation. There's just the elongated phone app on the side when you flip it, right? When you just drag it there. There's the middle of the screen, so you can move it to the middle of the screen, and that takes half the app, so your app really runs in half screen. Or it can be running on 3/4 of the screen. So our designer was very difficult to use with this concept. It was very difficult because the mental model that we built was incredibly hard to get right. And we completely redid that code. So if you tried our iOS designer and were very frustrated with the way that you work with this, you'll be happy to know that we fixed that problem. And essentially what you do now is when you create your user interface, you click the little button. It looks kind of blurry on the screen. But if you click that Edit Traits option, you get to choose which model of the iPhone you want to edit. So any changes that you do to the UI will just apply to that particular configuration. So you can say this button, let's say that you have a wide iPad display. So in that configuration, you'll add more buttons, for example, right? And when you go out of the edit trait mode, it will just remove those buttons. Right? So it automatically takes care of changing any properties, any UI elements based on the size classes. And that is how you're supposed to be building applications for iOS. So completely new. You should take a look. If you were frustrated in the past, it should be a thing of the past. Now, this is a preview. It's not shipping yet. It is shipping on the preview. So if you install the preview, not the release version, you'll get this capability. This is another big feature request, which is people want to have split editing. So now you have the designer, and side by side, we can show you the AXML. This is not XAML. This is not the XAML of Xamarin Forms. This is AXML, the native file format that Android uses. So when you choose to build native UIs, this is what you use. We also completely redid the property panel. We have now also code completion on AXML that was missing before. And you'll notice on the video that when you actually drag and drop, where is this thing? When you actually drag and drop this element, it shows you where it got dragged. And you'll also notice here that the code completion can now reference as well string resources. So when you're localizing your application, you can actually reference those things, and you get code completion for those. OK. How do I do this? 1 second. All right. Now, in compilation, we fixed a number of bugs in our dependency tracking. Mistakes were made, just like some companies apologize for their passwords being leaked. We apologize for getting a dependency wrong here, and the difference is very visible. It used to be that we recompiled everything every time in some scenarios, not all of them. But we fixed this problem, and now you can see that now a rebuild takes almost no time, while the other one is still running. And you can see that Puppy is still doing things on the left side. The other one is already gone and started again. So anyways, we're very happy about that one. Thank you for your patience as we fix this problem. Now, deployment, this is a big deal. You would think that in this day and age, this was obvious. But when you hit F5, what we used to do is first we would compile your application. And then we would do things in order. And then we would deploy the application to your device. Right? And the way when you do debugging, what you do is that you need to deploy the Xamarin runtime to the device first, so that for subsequent updates just deliver a small payload. with your changes, right? Every time that you make a change, you would just deliver the change. But we get to install first the runtime on the target device. And we did this serially. So what that meant is that when you build, and you had to wait for your build to finish, now we started the deployment to the target device. Well, in retrospect, it's obvious, but we should start the deployment to the device and start the emulator as the build is beginning, right? So these are a couple of statistics. So on a fresh machine with the Android emulator not turned on and everything, the first run for a sample app goes from 106 seconds for the first deploy to 81. And for the big, fat, smart hotel application goes from 179 seconds to 161. So not as noticeable for the big apps, but every second counts. Now, this table, I wanted to memorize it. We're going to have a test at the end of at the end of the session. You cannot leave the room if you haven't memorized this. So when you had to build Android applications on Windows, you essentially had to go through this decision matrix here, where you had to pick your poison between a fast emulator, slow emulator. And when we're talking slow, we're talking launching the emulator takes like 4 minutes. Or 8 minutes. I mean, this thing is slow, right? The guy, the gentleman over there is nodding. And it depends on what your CPU is. It depends on what services you want to use. Sometimes you made a decision, then you got to regret. And in fact, the decision-making process went something like this. You had to choose if you wanted to build, if you were OK just targeting all the operating systems. So in that case, you could get a fast version. You could get the Xamarin emulator and the Visual Studio emulator. Those were pretty fast. And then you had to ask yourself, do I want to run Google Play services? And if you said yes, then, well, you got to Google for this thing because we could not redistribute it. So you got to go to Google, and you find this Russian website or another website in Cyrillic. You download this thing. It's a RAR file, so now you got to get yourself a tool to unpack RARs, which I don't know why Russians like that thing. But anyways, you download that thing, and there's an ad, and the virus thing pops up, and it's very sketchy. This stuff is very sketchy. And eventually, you get Google Play services running on your Android device. And probably for free, you also get a blockchain miner. And then, chances are it would be OK. Well, we don't know. We don't know. I really don't know. But if you didn't need to use Google Play services, you were OK, as long as you stuck to Android 4. If you wanted anything newer, then you were out of luck. So in the modern world, if you wanted to use a modern version of Android, then you had to ask yourself, do I need to use Hyper-V? Either because I'm running on Azure, or I'm using a VM, or I'm using Docker, or building UWP apps, or any of the reasons why you would use Hyper-V. And if you had to do that, then you ended up in your slow emulation mode. And this is the 4-minute, 8-minute just to start up the emulator. And then typing is worse than, it's pretty bad. But if you didn't need Hyper-V, you were on the happy path. You were on the road to happiness. Except if you had an AMD CPU, then you're back to slow emulation. But if you had an Intel CPU, you can install Intel Haxam. God knows what it does, but you get to enjoy your development. So this is one of the collaborations that we had with the Windows team. And I have a little video to show you how, well, actually, I can show you live. So if I can figure out how to, this is 7. I can show you this live, or I can show you the video. But this is a collaboration with the Windows team. So the Windows team went and made changes to the Windows kernel. I didn't think this was going to be possible, that we came in and say, hey, Windows guys, you think you could do this? And it's like, yeah, sure, we'll do it. So they modified the Windows kernel. They extended Hyper-V to support the Android emulator. In fact, these changes also improve QEMU. So if you use QEMU, you will get this. And we're contributing all the patches upstream, both to Android and the QEMU community. So now you're going to have a pretty fast emulation for some of these. But I'll give you a taste of how fast this works. There it is. And we're done. And on Visual Studio, the experience should be, again, this is not my machine. Piers was very kind to give it, to let me use his machine. I was just going to go with, for the video. But so what do I need to do here? OK, so there you have it. That compiled, that deployed the runtime, and it's running it. It's running. Don't worry. There's a bunch of messages, so it's good. It's all good. It's all good. But what is really interesting is that this went from really taking 4 or 8 minutes to nothing. So now I can I'm actually running my Android app here. Oh, there it is. I guess Piers doesn't do the tap feature that I do. So there you go. There you have it. Visual Studio, Android emulator, super fast. And but I think it's worth watching this video because this is a full file new experience. With this new capability, this is your file new experience. So from scratch, in this video, we're creating a new project from zero, never been compiled before. And you can see that it's not going to take too long because we're already in. Oh, there it is. We're almost done. Boots the Android emulator. That's going to do the deployment thing that we talked about. We're almost there. Look at that. And the app is running. Takes a little while to do whatever it does. There we go. Oh, so nice, so nice. Anyways, so now I can go back and focus on the things that I care about. All right. So there you have it. So what do you need to do? Well, you need to get yourself the Windows April update. So the thing that was just shipped about a week or 2 ago. So the gentleman here is already launching his updater. So you need to do that. You need to enable the Hyper-V capability and then download our alpha preview. And our alpha preview with the new emulator has this. The good news is we're submitting all these changes back to Google. So from now on, Xamarin developers or Android developers or any other developer using the Android ecosystem will get a fast experience on Android. OK, now the other thing that we're doing for you, this is the page that takes a long time. So I actually went and screenshotted the documentation that you need to provision your device, your iOS device, right? And the reason why this page takes so long to display is because these are the actual screenshots. So I went and screenshotted this thing one by one. No, I printed to PDF, then I went and exported, and then copy pasted. Anyways, these are the full images. So when you download the presentation after you leave, you'll see that these are 2 megabyte images each. But this is what you need to do when you do manual provisioning of your device. And what does that mean? Well, when you start with iOS development, you're going to take your iOS device, you connect it to your PC, and then Apple is not going to let you just sideload anything into it. You need to get that device approved. So for that, we're going to do a couple of things. First, you need to submit a certificate signing request. And you're going to say, I am Miguel de Casa, and I want to provision a device. And here's my public key, and I'm going to have the private key that allows me to use that key. Apple is going to go and do something on their website, and eventually you'll click something on their website to download the provisioning profile. You're going to drag and drop that into Xcode, and that thing is going to put that into the device, and it's going to enable developer mode. First, we're getting there. We're getting there. So I missed a couple of steps. Then the second thing that you're going to do is, and you need to register your device. So you go and copy paste that little, the UID of your device, and you paste it on the site, and that will generate the provision profile for that device. Then once you're done with that, you're going to add some capabilities. And for that, you're going to need to get a provisioning profile that actually reflects the capabilities that you need. So if you want to have access to photos, you want to have access to the camera or iCloud, you got to go do this thing, and you repeat this process over and over. So this is the manual documentation that we have, and the colors represent the different pieces of the different paths that you have to take. So what we did is we decided to fix this problem using Fastlane. And now with automatic device provisioning, we use the open source Fastlane project. We integrate into Visual Studio, and off you go. And this takes care of everything. So what you do is you connect your device, and in fact, we'll tell you, hey, it seems like you just plugged an iOS device into your machine. Would you like some fries with that? And we take it from there. So right now, it already got all your credentials. It got everything, and your device is provisioned. And off you go. And when you add capabilities and you add any, well, here's what it's doing is we're going through the process of saying, I'm going to create an app for me or my organization. These are the capabilities that I need, but it does everything for you. This process, the first time that I did it, when Apple first launched the iOS program, took me about 2 or 3 days. And part of the reason is because you got these error messages that were undocumented, were ungoogleable. Remember, they were under NDA, and you could not figure out what was wrong. So now these 3 days of provisioning, eventually I mastered it down to like 3 hours. And so I really dreaded getting a new iPhone device because there were going to be 3 hours of this nonsense. And now it's done. Now it's all done. Now we provision your device in, I think, less than a minute, that we handle everything for you. So very happy about that. And I have to say, the 3-hour process of provisioning was what happened in 2011 or 2009. I think that by now, I got it nailed down to like 30 minutes. So in 30 minutes, I could do the whole thing on a new machine. So now we went from 30 minutes to seconds. Well, 1 minute. All right, let's talk about the debugging and running. One of the things that we've done with this past release is that now the Apple simulators, or remote Apple simulators, are available for everyone. They used to be only available for enterprise customers. Now they're available for everybody on the face of the earth. You should applaud. Oh, never mind. Don't do it. Don't do it. So they're available for everybody, and now you can run your simulator directly from Visual Studio. The other thing that we just added is wireless deployment. So once you provision your device for the first time and you pair it, you no longer have to connect it. We'll deploy your apps wirelessly. We'll debug wirelessly. So you don't have to be tethered anymore. Yeah. Very good. All right. Now, one of the problems that we have is that one of the ways that you lose your customers right now is if your application is too slow or your users have to wait too long. And what happens is, in some cases, your application will be killed. So if your application is inactive, the operating system will kill it, and it's going to have to do the whole process again. That's one thing. The other one is some of your applications might be very slow. So if you multitask, OS will kill it. If you reboot the machine, OS will kill it. If the operating system needs some memory, the OS will kill it. And your users typically want to use your app for maybe 60 seconds. If you're lucky, you'll get 10 minutes. But they're standing in line waiting for the bus. They want to launch the app. And if your app is low, you've lost them. So I just want to do a quick poll. If you purchased a new Android or iOS device in the last 2 years, can you please raise your hand? Wow, a lot of 1%ers. All right. So so these are the results from Geekbench. Geekbench essentially shows you the kind of device, the performance of your devices. So raise your hand if you have an iPhone 8 or an iPhone X. All right, so you guys have the fastest devices around, and the iPhone X is as fast as one of the Mac of the desktop Mac computers. Laptops. So the problem is that all of you that raise your hand, you're essentially this group of people, right? That's you. And I removed a lot of entries here, so this is not the full list. I actually trimmed down a lot of numbers, but you're essentially in that group. And when you debug your applications, and when you debug and test and iterate and create your beautiful experiences, that is what's happening. And the problem is that your users are at the bottom, right? And the problem with this chart in particular is that some of the bug reports, the one that I'm going to show you in a second, it's a device that is not even listed here because it's even slower than that, right? So it's not even listed. I couldn't even get the number for that device because it's so bad. So the problem that you have is that you folks are testing your software in an iPhone X or a Pixel, and your users, that's not what they have, and their experience is miserable. So we do need to fix that. So in this particular case, somebody came to me and said, hey, Xamarin is incredibly slow. What is wrong with you guys? And I said, oh, well, what's happening? So we talked, and he said, in fact, they have this application that takes 12 seconds to start up. Like, oh, my goodness, what is going on? This is really bad. My Pixel, I run your app, this is like, it's instantaneous. What are you doing? Maybe there's a network issue. And he sent me a picture of the device. So let's talk about that. I was asked to not put brand. Ooh, well, there's a brand there. Anyways, this is an old device. This is an old device. It was introduced in 2011. It's a Samsung Young. It's a 1 GHz CPU. is not a 64-bit 1 gigahertz CPU. It doesn't have a lot of cache. It's not even a very fast device. Look at the download speed on that thing. And the problem when we investigated was that the particular application that was taking 12 seconds, I said, what are you doing on the start? I said, can you give me the source code? I can't give you the source code. It's proprietary information. Can't do that. Can't do. I can't do that. All right. Well, the customer won't give it to us. So I downloaded the app, and I ran the profiler on it. And I discovered that the first thing that the application said, is your app doing anything? It's like, no, I just opened a file. I'm like, well, no, opening a file is a microsecond thing. I mean, that thing is, you barely notice this. So I looked at it, but what he was doing was he was opening a file and loading a massive JSON file, which of course triggers JIT compilation and Newtonsoft and deserialization and loads all kinds of junk, right? It's like, but what is this thing doing? Why are you loading these megabytes of junk at startup? It's like, oh, it's our localization thing. So they have this huge JSON file with localization to all of the languages that they support. And the entire app is localized with this very creative JSON thing. I hope you're not in the audience. But the first thing that they did is Android and iOS have native libraries to do localization. They're very efficient. They're incredibly fast. It's an optimized database, a binary file format that can do this on demand, doesn't need to load all the junk in memory, nor spend the memory. So the app A was using tons of memory, and B was killing the startup. So you really need to think about when you're building these mobile applications. I know that is very tempting. I mean, folks, I have an iMac Pro on my desk. It's amazing. I can even run Slack on that thing. And the problem is that when you build this software, your users are on the other end of the spectrum, right? So, and in fact, I can run multiple Slack rooms. So here's my guidance. So first off, use the profiler. And we're introducing a couple of things for you. First, the profiler was very, very heavy for some of these things. I understand why some of you might not have profiled your application. The data that it generated was too much. And in a device like this, it was very difficult to get the data out. So we implemented this new thing called light allocations mode. So it generates a lot less information. I'll give you an example. When we tried to profile Visual Studio for Mac using the profiler, we could only profile Visual Studio for Mac for about 30 seconds before we ran out of memory on a 64 gigabyte Mac. So with this thing, we can run Visual Studio for Mac for about 4 hours and not notice the problem, right? So this generates very little data, and it still gives you actionable data about this. So you should take a look at our new light allocations mode. The other thing that we introduced is we introduced snapshot comparison. We used to have it, but now you can have multiple snapshots, and you can actually track down where you're retaining the objects and where you're creating strong cycles or keeping memory data in memory. And the nice thing about the snapshots is like you can snapshot on different stages of your app. So you can say, well, here I log in, here I look at the cart, here I added the item, here I removed my thing. And now you can compare which objects were created between those two, so you can identify exactly what you messed up. So all of this is new, and we just released it yesterday as well. So the bottom line is, what can you do? Well, these are some hints of what you should be doing. First of all, you need to profile your applications. There's no excuse for that. The second thing is, a lot of you are just using the most convenient mode, and you're still shipping without LVM optimizations on. It takes longer to compile. In particular, on Android and iOS, these can add 2 or 3 minutes to your build for a large app. But for your release builds, you do need to use LVM. You know, really do a static compilation and use LVM. Don't rely on the JIT compiler. The JIT compiler will take a performance hit, in particular on those old devices. And my other bit of guidance is get yourself an old device. So luckily, we have a farm of machines at the office. So when this guy told me this is what the device looked like, I went to QA and I stole one of their old devices, and I ran the test, and very quickly I found what the problem was. So do yourself a favor, go to eBay and buy one of those old 2011 devices. The other thing that you should do, and this is very cheap, you don't need to go to eBay and you don't need to denigrate yourself. You can use on the Mac this tool called the Network Link Conditioner. And what it does is that it's a firewall filter rule that essentially will drop a lot of packets and will simulate different network conditions. So people using edge networks, 3G networks, a terrible network, a Wi-Fi at an airport, right? So you have all these profiles here. You can see it there. I have the high latency DNS. And just remember, because you're going to test your application with your own hotspot, but your users will be using, will be at an airport with a crappy little Wi-Fi shared with 100 people, or they're going to be even worse using GoGo in-flight. So you want to test your app here, and once you start doing that, you'll realize very quickly that you do not want to ship JSON. You really don't want to ship JSON over the wire. You don't want to do that. You don't want to do it. I know that some of you feel very passionate about this file format, but you don't want to do it. First off, I know that you're going to say, Miguel, you're wrong. You can just gzip the output. Good point. You have to pay the price for decompression. So just keep that in mind. And also, it's a ton of data. So you want to use something like the binary JSON encoding if you have to do that, or you can use protocol buffers. And this becomes obvious once you turn this on. And if you come to my Mac, I can show you the other options. But you very quickly gain a new appreciation for how bad JSON is and how wrong you're doing it. The other thing that people do very wrong, and we're trying to help here, is there's a whole revolution for using REST APIs. And people love their REST APIs. And part of the problem with the REST APIs is that usually when you're trying to do a screen full of content, you end up, you start with one REST API, and as you add features, and management comes like, could we add a little thing here that shows the total balance? It's like, yeah, sure, we'll do it. Another REST API call. And you add REST API call after another, and next thing you know, you're doing 10, 12, 40, 50 REST API calls to get your data. And so there's something, I'll talk about some of the things that we're doing in that space in a second. But what you want to do is, you don't want to do this. You want to do one request. Remember, you got to simulate what this is going to be like for real people in the world. So we'll come back to that in a second. Now, let me talk a little bit about what we're doing in the platform. First, with iOS, we used to have a full static startup. And over time, as Apple introduced new capabilities into the platform, we kept adding dynamic capabilities. So we went to a dynamic route. And what that means is that at startup, we had to pay a price to do some introspection. And I don't get into the detail, but essentially, we spent a lot of time allocating objects and doing reflection internally, and this burned a lot of time. So I'll give you an example. So one thing that we've done is that we've actually invested into completely killing that dynamic capability, and now it's all statically compiled. So there is no more dynamic code. Every single object and every single property and every single protocol is registered at startup so that we never pay this price. And this, in particular, is very helpful for Visual Studio for Mac. It reduced the startup time from 11 seconds to 7 seconds. So, and this is what happens on my desktop computer. Imagine what it does. OK, it was a large app, but imagine what it does for a mobile device. Now, what is interesting here, so you'll see here, this is the memory usage caused by the startup thing. So our improvement in this release, the one that was released yesterday, is for an iOS application is 34%. And more importantly, for extensions. A lot of you are building extensions for the sake of surfacing your app in different contexts, so not just launching the app, but like when you want to share something, or you want to edit a picture, or any of those things. And extensions actually run with a more limited amount of memory. The amount is not documented. We have some anecdotes of how big that number is, but Apple does not document that size. So bringing that size down was very important. And what we like is that now we got that number to be the same as Swift. So we're on the same ballpark. We're not spending more memory than Swift would do. So that's very good. So you should go and recompile your applications today with full static. I am running a little bit short of time, so I'm not going to go through the entire mechanics of the iOS weak attribute. But I just want to say that there's a pattern. There's a pattern that iOS developers follow when you have a view and a delegate. When you have a relationship between container and containee, where the container points to the containee and the containee points to the container. And usually with .NET, this is never a problem. We have a garbage collector. It can get rid of both. But in iOS, this linkage is called, it uses reference counting. And once you introduce reference counting, this cycle becomes a strong cycle, and it's not possible to remove it without help. We handle almost everything except this scenario. And we spent years trying to solve this scenario, and we couldn't come with a scenario, a way of fixing it. So we ended up, you'll get the slides to get all the data, but we ended up, the way that you fix it is you introduce this ugly syntax, weak reference of T. And then every time you consume it, you need to use this ugly thing where you have to call try get value, and then you can use the value. So we introduced this new change into the platform where you just put the weak attribute. So the containee, when you point back to your parent, the rule is very simple. If you're pointing back to a container, you put the weak attribute, and you're done. Done. That's it. So that's how you fix your leak. Thank you. Thank you. And this is only an issue for iOS native APIs. It's not an issue for forms. It's only a problem for iOS native development. And in fact, if you read any Swift tutorial, this is exactly what they tell you to do. So whenever you look at a Swift tutorial and they say put the @weak on a property, that's the same rule that you need to put here, except you use brackets. Now, Xamarin Forms is I'm going to talk a little bit about Xamarin Forms, is our open source stack for building cross-platform applications, write once, run anywhere. We support all those 4 platforms, iOS, Android, Windows, and Mac. And if you want to, we just released this version yesterday, 3.0. If you want to hear more about this, we have a lot of other things. These are the top features in 3.0, but there's a lot more where this came from. You should go to the session later today with David Ordinow. We've introduced a couple of capabilities. Flex layout, it's something that we borrow from the web. CSS, because it makes Flex layout just work so much better. Visual State Manager, and David has great demos about this. And finally, support for our friends that speak Hebrew and Arabic, and we support right-to-left languages, and also Farsi. Also, we launched this project called Xamarin Essentials. So over the years, there's a couple of gaps in the story where people needed to get a NuGet for some cross-platform capabilities. These are some of the services that people tended to just use an abstraction. And we had a lot of this, and it was different levels of maintenance, different APIs, different coding styles, different everything. So Xamarin Essentials is just a library. It's not tied to forms. It can be used with native or with forms that provides all of these APIs in a cross-platform way. So if your application doesn't need to really get to all the small little details of the platform specifics, we have this library. David will also talk more about this in his session. We have also started in January a thing called the Forms 100 project, which was the top 100 paper cuts and annoyances that you reported to us. You said, hey, how is it possible that you guys could not fix this thing? It only takes 10 minutes to fix. So we've gone through 100 of these things, and I think that the count now is much higher. If you count them, it's actually something like 150 now. So we've been fixing all of those. Some of them landed in 3.0, some are in 3.1, and some are in 3.2. But we're getting all your paper cuts out of the way. Now, just want to take a couple more minutes to talk about what happens after build. So everything that I show you today are things that are shipping in production or in preview, so almost about to ship. So there's a couple of things that we're experimenting with, and that might be interesting in the future. So first off, Don Syme from the F#, the designer of the F# language, has been exploring new ways of building mobile applications. Now, many of us have grown used to XAML and MVVM patterns, and we're very happy with that. But there's a lot of repetitive code. There's a couple of editorialized things happening on Twitter right now. People saying, well, do we really need this thing? Is this really the right approach? So Don has been exploring bringing this web framework. Well, it's a series of concepts that come from a web team called Elm and Elmish. And he's exploring how do we bring those to the mobile app world. Now, those of you that have done React programming will notice that this is very, very similar to React. What is even more interesting to me is that the amount of code that you have to write is ridiculously low. A full application written with Elmish takes a fraction of the lines that writing the equivalent code in C# and XAML take. There's no division between models and model views controllers and all these files and more files and not standard projects and all this garbage. All this abstraction. And so it's a really elegant model. There's a URL there that you can click. And this, like I said, is the designer of the F# language. And this is just the simplest program that I could get on a slide without, that you guys could still read, folks could still read. But he has bound the entire Xamarin Forms API. And what is really nice, one of the things that Don said to me is like, what I really like about this model is that now when I see a bug on the screen, I know where to fix it. There's only one place where this bug could ever be introduced. There's no 2 places like it happens in XAML. In XAML, it's like 4 places. But anyways, there's no multiple places. There's only one possible place, right? This takes the concept of don't repeat yourself to the logical extreme, right? So it's a very interesting model. Right now, it's built at F#, and we're if this works out, we'll see what it takes to bring it to C#. And right now, this relies very heavily. I don't know if you noticed this on the type message on the top. And the reason why you care about this particular one, and there's a new line missing there, is because this is a discriminated union. And you don't see it here, but with discriminated unions, you can have a payload of extra data for the messages. So in this sample, you don't need it, but for bigger samples, you would. And this is just obnoxious to do in C# today. So we're hoping that we'll get some of this work in C# so we can have a super smooth experience also in C#. Then the other thing that happened is once we open source Xamarin Forms, people did all kinds of crazy things. So first, they took Xamarin Forms to WPF. They put it, they put it on Tizen. They built a Linux backend. So now you can use Xamarin Forms to essentially target anything. But one thing happened that was very interesting. My friend Frank Kruger took Xamarin Forms and said, I bet you can run Xamarin Forms apps on the web. So he did it. And he did 2 things. He made it run on ASP.NET Core, so now you can take Forms code that you built for mobile and slap it on an ASP.NET server. So there you go. There's your mobile user experience for your web for your mobile.company.com. But here's the other thing that happened. We made .NET run on the browser with WebAssembly. And we made Forms run on the browser. So it's almost like Silverlight is back. I shouldn't say this. I'm sure that I'm going to get fired for that. But yes, so now you can run all this stuff on WebAssembly. It's kind of incredible. Now, I didn't do it. I'm going to say this is the community doing it. You folks did it. The .NET team has done this with Blazor. So Blazor is built on the same technology, .NET on the browser. Frank did WebAssembly. And there's my friends from Inventive did a UWP implementation that runs on the browser. So this whole thing is full circle. So, very interesting stuff. This WebAssembly thing has legs. And, if you look at my Twitter feed, there's a link to the site. I have links to all of this stuff there. The other thing, going back to this thing about the REST things. So one thing that we're experimenting with is using this GraphQL system. So instead of sending multiple REST requests, what you do with GraphQL is that you collect, well, the binding. What this binding does with GraphCollect is that when you have a complicated user interface, we create a binding context, and when you display something on the screen, we'll collect all the little fragments that we need to display a particular piece of user interface. It might be your login, it might be the amount, it might be the other thing that your boss asked you about. All the different pieces that your boss asked you need to put, we'll collect them all in a single query, and we'll send one HTTP request to request the data, and we'll get one response, and we'll fill in the data for all of the elements. When you scroll, again, we'll pick up all the different elements, send one request to the server, and you'll get one request back. Mind blown. Yes, I know. So anyways, it's a prototype right now, and I would like you guys to try it out and tell us if we're barking on the right tree. The other thing that we're doing is that we've seen you build applications with very creative layouts that don't work well for customers. And the way that it starts is you start with a box, and then you're like, well, I would like to put a menu. So you go to the forums, and somebody tells you, well, you put an Xbox and then a stack layout and just put an icon there. But what about the animations? Like, well, this is how I did it. So we all ended up reinventing the wheel over and over and over and over away, and we did really bad wheels. These were squared wheels. So what we're doing is we've implemented this type, and this is the layout of the XAML. So essentially, you'll see that there's a bunch of places where you can plug your content in. And we do a couple of things for you. First of all, we handle the navigation for you. So the navigation that has always been difficult for people, and you get it wrong, and it's not perfect, and the back button on Android, and you fill the forums with questions, we handle that for you. We also handle the app links. So if you get a link now on the web that goes directly to the page, these will handle all the navigation and the nesting for you. So it's always been there, but it's always been painful to use. We wired it all up. I don't know why it's replicated twice, but this is an actual example. This is a real actual example, and this is the kind of user interface that you get out of this. Right? So you just fill in the blanks, and we'll take care of the rest. There's a bunch of more things here. So there are things like about boxes and settings, and you just fill in the blanks, and we'll make sure that your application follows these rules. We implement both shell, that will give you a general purpose UI, and also a material shell, which is a subclass of shell. And essentially, when you inherit a material shell, you'll get the Android look and feel. We do all the bindings for you for material. We get all the look and feel for material. We get all the extra elements, like the things. We change the menus, the placements, all of this for you for shell. And I believe this is the end of it. So I just want to give you a couple of next steps. There's a few more sessions here that you can listen to. Some of them are already recorded. You should go to see those ones after that. But my recommendation for all of you is that, like the Karate Kid, if you for the older audience among here in the audience, the lesson from the Karate Kid is really you need to wax on, wax off all day. And so the only way you're going to build great mobile applications is if you write a lot of code. So my recommendation is go out and build yourself an app a day, and do that for a month. So at the end of a month, you should have 20 apps. 10 iOS, 10 Android, and I think you'll be on the right path to build great applications. Hopefully this was useful to you, and don't forget to fill your application. And no, we don't. Oh, we're already past. So no questions. I'll see you outside. Thank you very much.